In this video, I am going to discuss Nh3 Lewis structure, formal charts, hybridization, molecular geometry, and also I am going to give you the answer of the question: is Nh3 polar or non-polar molecule? And also I am going to give you answer the question: in Nh3 Lewis structure, is all the atoms follow the octet rule? Okay, so let us first find out the valence electron for Nh3. Nitrogen is an element of group 5a, that is why it has 5 valence electron, and hydrogen is an element of group 1a, that is why it has 1 valence electron. But here we have 3 hydrogen atom, so 5 plus 3, that is we have totally 8 valence electron in Nh3 molecule. This 8 valence electron has 2 tasks at the same time. The first task is to connect these 3 atoms together, and the second task is to satisfy the duet for hydrogen and octet for nitrogen. So let's get started. So nitrogen is the central atom and hydrogen is always considered as an outer atom, right? So to connect, I have to use 2 dots or single bond, right? 2 dots. So for connecting these 4 atoms, we have used 2, 4, 6 valence electron out of 8. So we have 2 valence electron left. So these 2 valence electron must come over the nitrogen. Now look, this hydrogen has satisfied its duet, and this hydrogen also has satisfied its duet, right? And this nitrogen has achieved the octet. That is why we can say that in Nh3 Lewis structure, all the nitrogen follows the octet rule and the hydrogen follow the duet rule, right? So if you can express this structure like this: nitrogen, then hydrogen. You can express the bond pair using dash. So here we have 1, 2, 3 bond pair and 1 lone pair. That is, here in this molecule we have 1 sigma bond, 2 sigma bond, 3 sigma bond, right? In H3 molecule we get 3 sigma bond and we get 1 lone pair. However, now I will talk about the formal charge for hydrogen and nitrogen. So look, we know that formal charge equal to valence electron in neutral atom minus half of bonding electrons minus lone pair. So to find out the formal charge of hydrogen, so in a neutral atom of hydrogen we have 1 valence electron minus half of bonding. Here bonding valence electron is 2, and there is no lone pair over hydrogen. So we are getting here this 2, 1, 0, that is 0. So this hydrogen's formal charge is 0. So this hydrogen also, the formal charge of this hydrogen also will be 0 and 0, right? Now find out the formal charge of nitrogen. So in a neutral nitrogen atom we have 5 valence electron, then half of bonding. Here we have bonding electron 1, 2, 3, 2, 4, 6 minus lone pair. We have 2 lone pair over nitrogen. So 5 minus 3 minus 2, that is 5 minus 5, 0. So the formal charge of nitrogen here is also 0. So overall, if you add all the charge, then nitrogen molecule will be a neutral molecule, right? Now I will talk about the hydrogen. I will talk about the hybridization of nitrogen. So what is the hybridization of nitrogen? Look, to find out the hybridization, we have to have knowledge about steric number or number of electron region. So this is a electron region, this is a electron region or electron region. That is, every sigma bond and lone pair is considered a electron region. So here we have 1, 2, 3, 4 electron region or steric number. So we need 1s and 3 p orbital. That is, here the hybridization of nitrogen is sp3, right? sp3. Due to sp3 hybridization, the ideal shape of ammonia is tetrahedral, but the real shape of ammonia is trigonal planar. So what is the cause? That is, what is the geometrical shape of ammonia? You have to say trigonal bipyramidal. Okay. According to hybridization, its shape should be tetrahedral, but due to presence of this lone pair, the shape of this molecule is trigonal bipyramidal, right? Trigonal bipyramidal. I hope you have understood. And the bond angle is 107 degree bond angle, right? So now I am going to tell you whether Nh3 is polar or non-polar, right? So you know that in ammonia, right, every bond is polar because the electronegativity of nitrogen is more than hydrogen. The difference between electronegativity of hydrogen is greater than 0.5. That is, every bond is polar, right? Polar. Partial negative, partial positive, partial negative, partial positive. Since this bond is polar, so this bond will have a dipole moment. This bond also will have a dipole moment. This bond also will have a dipole moment, right? That is, in ammonia molecule, every bond is polar and every bond has dipole moment. So, and due to this lone pair, the geometrical shape of this molecule is trigonal bipyramidal, which is asymmetrical shape. That is, the bonding dipole moment will not cancel each other. That is why the net molecular dipole moment of ammonia is not 0, and this indicates that ammonia is a polar molecule, right? So when you will talk about the polarity of a molecule, you have to consider the shape also, right? The shape or geometrical shape of the molecule. Since ammonia ammonia has asymmetrical shape, that is, trigonal bipyramidal is asymmetrical shape. So the bond dipole moment will not cancel each other. So you will have a net molecular dipole moment. So this is polar.